Welcome you all lovingly to this video of Photosynthesis Systems channel. In a home or an institution, to install an inverter or to increase capacity of a previously installed inverter or to install solar panel, in regard to this, now we are going to share with you the last video, which is part 4 video. In part 1 video, we have seen how to calculate inverter and battery size. We have seen watt, VA and PF. If you did not watch it, please see the link shown here or go to end of screen or see its link in description. In part 2 video, we discussed some terms related to solar panel. To understand well, it is necessary to understand meaning of some technical words. It will help you to buy panels and install by yourself. In part 3 video, we see how to calculate solar panel capacity. Part 4 video is a subject of how solar energy is converted to electrical energy in solar panels. It is a wonder how solar panel produces electricity. Before solar panels came into existence, there are many wonders created by nature for us. Plants convert solar energy to chemical energy for their food. That is called photosynthesis. This is an example. Green plants make their own food. That is why they are called autotrophs. To carry out this complex process, plants use simple and organic substances like carbon dioxide, water, minerals like potassium, nitrogen, phosphorus. Green plants are the only organism having the ability to track energy from the sun to make food. How? Leaves are green. Leaves have the green pigment called the chlorophyll present in the cell organelle called chloroplast that tracks solar energy to convert it into chemical energy in the form of carbohydrates. This process is called photosynthesis. By heating water on earth to make it vapor and bringing the same water to earth so that every leaves, including plants, maintain their life is due to solar energy. We don't find anything new in solar panel that converts solar energy to electrical energy. We are only brought and came to understand existing information that nature has defined in atom structure of silicon, boron and phosphorus. We have only modified these three atom structures together artificially in solar panels. To understand this, we need to understand some electrical terms. We have explained all related terms in part 2 video. If you don't know terms like electricity, power, watt, voltage, current, etc., it is better you watch part 2 video before you complete watching this video. What is an atom? On Earth, each thing is made of many particles. We call it an atom. An atom is the smallest part of a material or thing. Too many particles make soil, which we use for plastering on wall or for concrete. Each of these small soil particles is made of so many atoms. It is like so many innumerable cells constitute a human body. Each material on earth has different structures and atoms. Structure of atoms. In each atom there is nucleus in the center. In nucleus there are two elements. One is proton, second is neutron. In each proton there is positive charge. In neutron there is neutral charge. It means no charge. Around nucleus there are electrons. Electrons are smaller than protons or neutrons. Electrons have negative charge in same strength of protons but in its opposite polarity. Since each proton has electron with equal and opposite charge, each atom stays balanced. So each atom is overall electrically neutral. That means atom is neither positive nor negative. When electrons and protons in an atom become unequal, that atom is called ion. An atom can gain or lose electrons. When it gains, that material will get electrically charged. This will happen when we rub a balloon or plastic on some fabric. When we rub electrons in balloon gets electrically charged due to friction. When there is imbalance of electron or proton in an atom will try to balance itself by giving electrons to or taking them from neighboring atoms. When electrons are more, atom will give surplus electrons to neighboring atom which has less electrons. When electrons are less, atom will attract surplus electrons from neighboring atom. An atom which has lesser electrons are called positive ion, and atom which has the surplus electrons are called a negative ion. It is because an atom tries to exchange electrons and balance its charge. Balloons attract pieces of paper and release them after it got balanced. What is electricity? An atom has a negative charge and positive charge. When an electric force occurs, electric charge in an atom is pushed out to positive charge in neighboring atom. When this movement of electrons occurs continuously, this causes flow of electrons. This is called electricity. Current is the negative charge carrier. Direction of electrons flow is from negative to positive points, but current flow direction is opposite of electrons flow. For example, when we walk forward, we apply force backward and pass to earth through our legs. This is the best example to understand electrons and current flow direction. This is the same you see in video now. Atomic structure of silicon, phosphorus and boron elements. Silicon is the main element used in solar panels, but it is not possible to create necessary electrons flow using silicon only. So we modify silicon atom structure by combining boron and phosphorus atom, and we use this modified atom in solar panels to generate electricity. Therefore, it is only when we understand the atomic structure of these three elements we can explain how solar panel produces electricity. You are now watching periodic table of atoms. Please see round marked elements of silicon, phosphorus and boron. Each element found in nature and their distribution of electrons, protons and neutrons are given in periodic table. We are now seeing silicon's atomic structure. There are 14 protons and 14 neutrons in nucleus. In outer three shells there are 14 electrons. In first shell 2 electrons, second shell 8 electrons and in third shell 4 electrons. In outer shell all 4 electrons are valence electrons. To modify silicon atom, boron and phosphorus are used as additive. In boron atom there are 5 protons and 6 neutrons. In two shells there are total 5 electrons. In outer shell there are 3 valence electrons. Second additive is phosphorus. There are 15 protons, 16 neutrons and in 3 outer shells 15 electrons are there. In outer shell there are 5 valence electrons. To make one freely movable electron, we combine silicon atom which has 4 valence electrons with a phosphorus atom which has 5 valence electrons, so one electron becomes free. To make one free hole, that is positive charge, in silicon atom, it is combined with boron atom which has 3 valence electrons. It is like these additives are added in silicon. How solar cells produce electricity? To tell it shortly, when sunlight hits photovoltaic material, it knocks electrons and make move electrons freely. When it occurs continuously, it causes for electric current. Photovoltaic cells are made by mixing silicon material with other elements. Photo means light, voltaic means electricity or voltage. It is some physical qualities found in silicon element that cause for selecting silicon to make the solar cells. In silicon atom there are 4 outer electrons. These 4 electrons will always try to fill the holes in neighboring atoms. When sunlight energy strikes the silicon material, electrons will be freed from its lattice structure, that is positive negative bonding. The problem of silicon is that it requires a lot of energy to free electrons, so only some electrons will be freed and current flow will be a little. Therefore, to increase current carrying properties in silicon, some impurities are added to silicon element to make solar panel. This process is called doping. Phosphorus and boron elements are used as impurities. Doping is the process of modifying conductivity by introducing and adding some impurities to semiconductor crystals. Boron and phosphorus are two important materials that are doped in silicon. Aluminium, indium, arsenic, antimony are also used as additives. How many valence electrons are there in an element? It decides the type of bonding. Difference between ionic bonding and covalent bonding. Bonding is the chemical process an atom's outer electrons try to complete a shell in that atom. There are two types of bonding we need to know in our subject. One ionic bonding, two covalent bonding. In ionic bonding, one atom transfers electrons to another atom. One atom gains, other atom loses. Thus, these two atoms attain stability. Losing atom gets positive charge, gaining atom gets a negative charge. Ionic bonding is always stronger than covalent bonding. In covalent bonding, two atoms share electrons. In ionic bonding, electrons are transferred from one atom to other. Ionic bonding usually happens between one metal and non-metal. Covalent bonding forms between two non-metals. You can understand well by looking at the picture here. Doping of silicon with phosphorus and boron elements. In silicon atom there are 4 valence electrons that can be shared with the other atom. In boron atom it is 3 and in phosphorus atom it is 5 electrons. Electricity is produced in solar panels by creating an imbalance in each atom by mixing these 3 elements. This imbalance is according to the reduction or addition of electrons or holes in mixing while doping. N-doping. When silicon atom which has 4 outer electrons is doped with the phosphorus atom which has 5 valence electrons, 4 valence electrons out of 5 in phosphorus atom will combine with 4 valence electrons in silicon atom. Balance 1 electron phosphorus atom becomes freely movable. Electron in one atom bonds with the electrons in another atom. This is not ionic bonding but covalent bonding. Fifth electron in phosphorus atom becomes free and becomes charge carrier. This free electron requires only less energy to move from valence band to conduction band. It requires only lesser energy than the energy required for moving the natural electrons of silicon. It is the main reason for modifying silicon atom and using it in solar panel. P-doping. When boron atom is doped with the silicon atom, 3 valence electrons in boron atom combines with the 3 valence electrons in silicon atom. One valence electron in silicon atom becomes free. In order to bond this free valence electron, one electron is taken from neighboring silicon atom. This creates a vacancy or hole in the atom where that electron is lost. This hole is positive charge. Like this, p-type semiconductor is formed. In p-type semiconductors, number of holes are more than electrons. In p-type semiconductors, holes are major charge carriers and electrons are minor charge carriers. In n-type semiconductors, electrons are major charge carriers and holes are minor charge carriers. In short, to create negatively charged silicon, silicon is doped with atom having more valence electrons. To create positively charged silicon, silicon is doped with atom having less valence electrons. Compound with extra electrons is called n-type and less electrons is called p-type. You can see in screen n-doping with phosphorus and p-doping with boron. How solar panel is constructed? Now you will see each layer in solar panel. In the middle in blue color you will see solar cells. Our subject is when sunlight strikes in solar cells, how it is converted to electrical energy. You are now seeing a cross section of a solar cell. There are two layers in that, N-type semiconductor layer and P-type semiconductor layer. As we said earlier, layer with N-doping is the N-type semiconductor and layer with P-doping is the P-type semiconductor. What is a PN junction? As we see in screen, N-type layer is manufactured and joined next to P-type layer in solar panel. In N-type layer, electrons are excess. In P-type layer, electrons are less, so holes or positively charged vacancies are more. Panels are manufactured like this. P-N junction is the junction where these two layers are joined. What is a depletion zone? Depletion zone is the region where mobile charge carriers are not present. It acts as a barrier opposing flow of electrons from N-type layer and holes from P-type layer. Depletion zone is created due to an electric field. Depletion region is very thin compared to N-type and P-type layers. Let us see a 2D structure of silicon crystals. N-type layer is the layer where 5 valence electrons from phosphorus atoms are injected. In this, one electron is freely movable. In this structure, when electrons receive sufficient energy, it will move freely. Let us see what will happen when we use this type of material only. When sunlight strikes the solar cells, free electrons will start to move. But this movement is random. This will not give a result enough to cause a current flow in load. In order to make a unidirectional electric flow, we need a driving force. The easiest way to make driving force is to make a p-n junction. Like n-type doping, if boron's 3 electrons are injected in pure silicon, in each atom there will be a free hole. This is p-type doping. When we join these two doped layers next to one another, electrons from n-type layer will migrate to p-type layer and fill the holes in the p-type layer. In other words, n-side holes will attract and make move p-side electrons. Thus, a condition will arrive where there are no electrons to move or holes to fill. Due to this electrons migration, n-side boundary will get slightly positively charged. It means after moving electrons to holes in p-side, n-side will have holes due to loss of electrons. Due to gain of electrons, p-side boundary will become negatively charged. An electric field will be formed between these two boundaries. That is, after electrons from n-side come to fill holes in p-side, around p-n junction, there will be an electric field called a depletion zone. This electric field will create the necessary driving force. In depletion zone, you already saw negative charges formed in p-type side and positive charges formed in n-type side. What happens when solar light strikes on solar cells? To tell it clearly, when solar light strikes in p-n junction, light hits on n region of PV cells and reaches depletion zone in p-n junction. This photon energy is sufficient for moving electrons, hole pairs in depletion region. Electric field in depletion region will make electrons escape. This will drive the electrons and freed holes to outside depletion region. Thus, electrons are concentrated in N region and holes concentrated in P region. Their concentration will become so high that a potential difference develops between them. Thus, it works like a battery. When we connect a load between N region and P region, electrons will start to flow. Electrons will pass through load and recombine with holes in P region. Accordingly, solar cells will continuously generate direct current. Like we said, solar panel generated DC electricity. To increase efficiency, N-type layer is constructed thinner than P-type layer. Electricity generated in this way is either stored in batteries or transferred to power grid using an inverter. Dear friends, I am happy if this video is useful for you. If you like this video, please subscribe. To let others know, please like this video and share it to your people. To watch new videos from this channel, please press the bell icon. Namaskaram till we see in another video.